So if you're an IPTP grade 11 student preparing for your resit in August or September because you lost some of the marks and you get not get the required grade, then this video is helpful for you. Why? Because I am solving a paper which is and I am exactly solving and I'm showing how to solve a paper and how to not lose marks. Because what you do, you people always think that okay, MCQs are easy, we are able to do it, and you lose your marks. This is an SL paper and I'm going to solve it and I'll show you exactly how to solve it, what to think, what not to think, right? And also the common mistakes that people do. So if you just watch this video and you can practice later on, right? Every question you pause it, you try to solve it and then I will solve it. You will automatically understand that how to solve it and your level of understanding and problem practice will improve. So without wasting time, let's begin. So this is again, I told you IBTP paper 1A. First question, look at the first question. That there is a person in the elevator, which is lift. The total mass of the person and the elevator is 800 kg and the elevator accelerates upward at 2 meters per second square. First understanding. If you notice being a teacher also, I am highlighting things. I am highlighting or underlining things. Why? Because brain will focus on those keywords, so I will not miss. Is the first thing you should do. Got it? Now, this is the setup they have given. It is accelerating upward with acceleration 2 meters per second square. Your first thing is you should remember free body diagram. What is free body diagram? FBD. Free body diagram is you just take the body and draw all the forces. So here I did the same thing. This dot I is representing the boy, the person, and the elevator. There are two forces acting on it. One is weight, another is the tension because there is a cable. Yes or no? These are the forces. And then the acceleration is happening in the upper direction. And then the acceleration is happening in the upper direction. Now, as per Newton's second law, remember these kind of questions, you always think about it. Whenever they give you forces and they will give you acceleration and mass, for sure, Newton's second law, because F equals to ma. So then what is Newton's second law? You should remember net force equals ma. Now, what is the net force? Understand. You follow the number line. Number line meaning upward is positive, downward is negative, right? So upward is positive, so tension is positive. Downward is negative, downward is mg, which is a negative, equals ma, right? Because acceleration is upward, so it is also positive in nature. Understood? Now just plug the values only. Tension, you don't know. If you make tension as a subject, you get tension equals mg plus ma. Just substitute the values. M is 800. G for MCQs, we usually take 10, right? Or 9.81, 9.8 also you can take. And MA, then just you put it. You get this part is 8,000, this part at 1600. You add it, you get 9600 Newton. But if you notice, they have given in kilonewtons. So how do you convert it? Kilo meaning 1000. So you divide by 1000. As you divide by 1000, you get 9.6 kilonewton. And which is exactly our answer here. Which is exactly our answer here. Understood? Let us move on to the next part. Next, yesterday I was solving this paper. I got I this maybe so I thought that just do it so it will help you people. Next, look at the second question. Again, pause it, do by yourself, and then check the solution and discussion, whatever I'm doing. See, again, this is an easy question. You just have to use logic. Have patience, do it. You are capable. Remember that. Do not underestimate your potential. You are able to do it. It just till now you didn't get a proper direction. I know that. But I'm here to help you to give you proper direction. Do it. We are able to complete this thing. We are able to sort it out. Let's do it. Okay. Yes. See, if an object released from rest in vacuum at a height h above the surface, and then as the object falls, it passes a point at a height of this 0.75 h above the surface. Remember, when there is no diagram, make the diagram. It will give you more clarity of that question. So this is that same thing I did. This is the ground. This is the earth surface. Initially, the object was at A, and you know that as you drop it, it was at rest. So it was at rest. Now, when it was at rest, the kinetic energy is zero. The potential energy is mgh because height is h. And then when it was at point B, whose height is 0.75 h, it would be moving. We don't know. It would be moving, right? Let us look at the question. They are asking the kinetic energy, gravitational potential energy, is why I didn't use sweat right now. Kinematic equations, I didn't use. I used these things. There is one more thing I need to tell you. Remember, guys, if you are facing, let us say, I am a little bit faster for some people, slow it down. It's in the video. If I am slowly, right, if I'm slower for some people, increase the video. You can do that. So I'm just try to solve in minimum amount of time so that it will be not it will not be a burden for you. Understood? Listen, whenever they talk about energies and all, we always do that. Important point is here, have they discussed about air resistance? No, nothing is there. So meaning resistance is not there. There is no energy loss. If there is no energy loss, then you should remember what we're gonna do. The total energy at A should be equals to total energy at B. What is the total energy at A? Only the potential energy. Then at B, there would be kinetic, there would be potential. So total energy would be kinetic plus potential. And this should be equals to the energy which is at A, correct? Which is mg capital H. And now the kinetic energy at B, we just write it Ke, but the potential energy at B is mg height from the surface. And right now the height from the surface is 0.75 h. 0 mg h, right? 0.75 h. 0.75 h is the height, right now. Then you just make kinetic energy the subject. So if you make it, you will get mgh minus mg times 0.75 h, right? Mgh you take as factor or common. From here, if you take it, you will get 1. From here, if you take it, you get 0.75. 1 minus 0.75, you will get 0.25. 0.25, if you know, it is 1 over 4. But still, you just take it, huh? Because they want kinetic energy. So kinetic energy is this, right? We derived it. And then initial total was gravitational. Gravitational was mgh. Mgh cancel out. You get 0.25, which is equals to 1 over 4. Or you can just check the ratio, which ratio is giving me 0.25. That is fine. I hope you understood this question. It's easy. You can do it. Let us move on to the next question. Again, this question is a little bit tricky. Most of the people would have lost marks here. And eventually, if it comes, people will lose mark here. So we need to be smart, right? Anyway, you are smart, but we just need to be a little bit smarter, even more, right? Now, so see, there is a weight, like there's a bird who sits in the middle section of the two string, in the middle section of a string. So automatically it bends down, right? The rope is almost horizontal, and we need to check the tension is greater, less than, and all of that. The smart technique is that I will not do the question in the first place. I will do when I'll come back. Because this is a little bit tricky question. I read it, I didn't understand. I'll just move forward. Because people will waste time here and I will not. Understood? Then I'll come back later on and I'll do it. Because anyway, I just have to mark the answer. Understood? Never ever leave any question. Never ever. Because no negative marks are there, right? So attempt it. Now listen here, what is going to happen? What is this? Again, remember free body diagram, body plus all forces. So if they have given that W and there is a single string, but there are two sections of it, so you will have tensions but equal because there is a single string. If there would be two different strings, then it would be T1 and T2. But here, because there is a single string, two parts, same tension. But you should remember, whenever we consider a point, tension is always away from the point. So tension is always away from the point and along the string. Tension is always away from the point along the string. Understood? Now, tension is always away from the point along the string. You made it. Now, if you notice, the tension is neither horizontal nor vertical, right? So what is the first step you should do? You should make a horizontal line because they are talking about rope is almost horizontal, meaning something related to the angle. Draw the angle from the horizontal for the strings. Angle should be same because it is in the middle. Now what is going to happen? You just resolve your tension. Why we are resolving? Because tension is neither horizontal nor vertical. Let us resolve it. When you resolve it, this is the angle. So component with the angle becomes adjacent and adjacent takes the cos. And component without the angle becomes opposite. Opposite takes the sine. Same thing you do for the other tension, which is on the right side. You get their components. Now, once you get all the forces in vertical and horizontal directions, then you do this. Again, what you have to do, you have to just balance it. Why? Because this bird is not moving, right? So the forces are balanced. So we will balance the forces in horizontal and we will balance the forces in vertical separately. If you notice horizontally, T cos theta are balancing each other. So there is no net force. But in vertical, if we talk about total upward force will balance total downward force. Total upward force will balance total downward force. So it is 2t sin theta equals to W. Understood? Important is because they said rope is almost horizontal, meaning angle is so small, correct? So angle is so small, meaning angle will be very close to zero. You can assume, not very close, but let us say it is 2 degree. It will be 1.2 degree, 1 radian, whatever. Take 2 degrees. So if you put it and you solve it, you get almost 14 times W. If you notice, which is greater than W, yes or no? Which is greater than even 2W also, but which is greater than W as per our portion, as per our the options. Is it less than? No. Is it equal? No. Is it between then? No. It is greater than W, yeah? Greater than W. This is a tricky question and that's how you solve it. What mistakes people do? People think that okay, it is horizontal, so angle is almost zero. Either they put zero, automatically it is not defined, you will not get it. And sometimes they say 0 degree, sine 0 is 1 without using their calculator. Use your calculator, yeah. Okay. And angles, make sure your angle is in proper unit. If right now we are talking about degrees, it should be in degrees. In some questions, if it's in radians, make it in radians. Understood? This is the mistake. Most of the people, most of the people choose this option. Most of the people. This option no, is not correct at all. This option is never a valid option. This option is valid when the strings are almost vertical, like this, and they like this, and in between there is a bird sits. Then tension and tension will have no angles. So what happens here? Notice T plus T, which is 2T. 2T will balance W. When the ropes are almost horizontal, then it happens. Understood? Good. Let us move on. Now, if we talk about the next question, again I solved this, but this is again people find it really difficult. And literally, if you didn't get the proper method, it is a difficult question. What is the thing? I will not do it. I will come back later on, then I will do it. I will not waste my time. Remember, in paper, what matters your confidence, right? So I will do those questions which will give me confidence, meaning those questions that I'm able to attempt. I'm able to get the answers. The questions which are difficult for me, I'll not do it. I will come back to them later on. That is the strategy for attempting the paper. Understood? Let us move on. Now, in this question, if you notice, they have given what? They have given two bodies, it's just collision in 2D, right? So, in a horizontal frictionless surface, meaning no energy loss is happening as per the friction. Body X masses are given, speed is given, and body Y it was initially at rest and it collided. After the collision, the body X moved vertically, meaning 90-degree to this initial direction. Initial direction was horizontal. So basically, it went upward vertically. And the second object moves somewhere we do not know. Remember, whenever you see three things, okay, and one of the angle is 90-degree, whenever it happens, because they might repeat this question, it's a good question. Whenever you see this same pattern question, that one particle comes, collides, and then goes in the straight line, like vertical. So 90-degree angle change. Whenever this will happen, you always use Pythagoras. This is the shortest method to tackle this question. And in exam, this matters more than the concept. Concept is collision in 2D, right? You're gonna resolve the momentum here, horizontal and vertical, and then horizontally, what you're gonna do? Horizontally, total initial equals to total final. Vertically, total initial equals to total final. If you ask me, drop a comment. I will record a video for that properly. Collision in 2D with some questions of the past papers. How to solve it, how to think, and understand how to approach the question. Now, in this case, what happens? Just use the Pythagoras. Pythagoras, how do you get it? If you need to get this part, they are asking the question check. The magnitude of the momentum of the object. Why? Whenever they give you three things, right? And one is two things are 90 degree. You know that in right angle triangle also, the whenever two things, those two things in either of them becomes adjacent and other thing becomes opposite. So the third thing automatically becomes hypotenuse. So let us say this one is opposite, this one is adjacent, so this one becomes hypotenuse. How do you calculate hypotenuse? Pythagoras, correct. So you get the momentum here by multiplying mass times velocity. You get the momentum here by multiplying mass times velocity. And then you just take the under root of it, solve it with your calculator, you will get your answers. That much easy it is. If you solve it in 2D, again you will get the right answers. But it is a lengthier method. That's it. So for that, I'm telling you, whenever you see there are three things after collision, angles are 90 degree. One of the angle is 90 degree. Use the Pythagoras, get the answer for the third one. You just need to check. If they would have given this one, guys, if they would have given this one and they would have asked this one, what I would have done? Again, I would have used the Pythagoras, but this time I need to calculate either adjacent or right now here I need to calculate adjacent. So what I would have done, I use the Pythagoras, made the adjacent as a subject and get the answer. Got it? Fantastic. Let us move on. Now, fifth question, if you notice, in this fifth question, what is happening? In this fifth question, if you notice, they have given the car starts from rest at point S from here and moves in a straight line with a constant acceleration. Acceleration is constant, so I can apply SUAT. That's how we should think, because they have given distances, they have given acceleration, they have given something. Now they are asking that 2 points x and y are given from x. The cart passes x with some speed and y with some speed. We need to calculate it. See, speeds, acceleration, distances are given. So I anyway know that I need to use SUAT or kinematic equations. Kinematic equations, right? I hope that you know the kinematic equations. Up here, what we should do. Acceleration is constant. They haven't discussed time. So I will not use any equation. I will not use any equation which consists time. So if you use your kinematic equations, you have one of the equation which does not include time. Why I use this equation? Because it does not contain time, and in the question itself there is no mention of time. So it's fine. My work would be easy. What I have to do? First I'll apply for x. First I'll apply for x. So again, for from s to x I will apply. So s becomes my initial and y becomes my final, correct? So final is vx square equals u square. Initial velocity is 0, right? U is 0. Look at the data. Write the data at one place and then solve it. No worries. So it is 0 square plus 2as. What is the distance? 0.5. So Vx square is 2 times 0.5, which is 1, right? So it will give me A only. And if I calculate Vx, it is root A. People make mistake here only. They don't do square root. They don't do square root. Okay, so make sure you do a little bit slowly. Now same thing we do for S to Y. So now your S to Y, if you notice, S again is initial, but your Y becomes final. So again, if you apply the same formula, now this is Vy square equals U square plus 2 times A times S. Vy square again we don't know, but U square is 0 plus 2 times acceleration is constant for entire journey. S right now is 1 meter. So Vy square is 2A. So Vy is root 2A, right? What we have to do? Vy over Vx. Put Vy over Vx. Vy is root 2 times root A, and this Vx is root A. Root A cancel out. You get root 2. Easy. But people will lose mark because they will not do square root. So do little bit slowly. You will get it. Got it? Let us move on. We have time, right? You are with me, right? Be with me. We'll try to finish, right? Let us with this question. This is a really good question, but it's a very easy question. See again, if there is a force getting applied on a mass of 3 kg, the graph is given how the acceleration of the particle is changing. So you can understand the acceleration is constant here, acceleration increases. Acceleration is constant meaning force is constant, acceleration increases meaning force have increased. But what the question they are asking? Meaning force change, right? So that is why they are asking average force. Force change, that is why they are asking average force. So how do you calculate it? Understand. Most of the people will do, they get the force which is F equals to ma. Ab now, sir, F equals to ma, but A. So they will calculate, they will calculate F here, then they will calculate F here, like take one of the value and get the average of it. That is completely wrong. Why they have given the graph then? In the first place, you should think why they have given the graph. Whenever they give you a graph, remember, whenever they have given a graph, always think in two directions. Think about gradient direction and think about area direction. Like in this case, if I think about gradient direction, which is acceleration over time, I never learned acceleration over time. It didn't give you anything, right? Nothing, you'll get it. But if you talk about area, you will notice area is acceleration times time. Area is acceleration times time. Sir, you taught me, like you have learned, that sir, area is change in velocity. Sorry, acceleration is change in velocity over time, sir. And if I multiply with time again, sir, then I will get change in velocity. Sir, meaning what what we are getting, bache log? We are getting area is giving me something. So I need to get the area. Now, what is the relation between area and average force? What should I do? Then I should think about it, right? What should I do? Always remember whenever there is something related to, you told me F equals to ma, you only told me. Use it, no? Newton's second law, F equals to ma. Now m you know 3. Acceleration is what? Change in velocity over time. This time is what? Total time, right? Because change happened in that time. Meaning from here, from this time to this time, the entire time, the change happened, yes or no? So that's it. You just apply it. Right? Get the area of it. Get the area of these sections. Get the area of this section. Get the area of this section. Get the area of this section. And get the total area. As you get the total area, you put it here, you get change in velocity. You put it in this formula, you get your answer. It's not difficult. For you, I am doing it. So if you calculate the area for first part, if you notice, this is 2, this is 1. So it is, for first, it is 2 times 1, right? For rectangle. So it is 2. For second one, if you notice, this one is 1 and this one, this section is 4 because 2 to 6 is 4. Again, it is 1 times 4, which is 4. For third section is a triangle, half times base times height. So half times base is how much? 4, and height is from 1 to 4, which is 3. So it is 4 times 3, which is 6. So if you calculate total, it will give you 12, right? So if you put it here, 3 times 12 divided by, what is the total time? 6 seconds. Cancel it, you will get 6 Newton, the answer. Easy. I am telling you how to think, how to solve, how to approach. I want you to understand why you lost marks. In every question, why you are losing marks. Understood? I hope it's clear. Let's move on to the next question. Always attempt a question by your side first, then move on to the next part. This thing. A mass m is attached to a string and moves in a vertical circle. I hope you have learned vertical circle. If not, then just let me know. I will make a video of it. Okay. Constant radius r is given at the top. So let us make it right. This radius is r. At the top of the circle, tension is given. Kinetic energy at the top, you need to calculate. Fine. So meaning at the top, first of all, at the top, again free body diagram. There is weight and there is tension. Tension is always away from the point. Correct? So in the string. So if you notice, the net force here is T plus mg. Yes or no? And this net force will provide centripetal force. Yes or no? So T plus mg equals centripetal force mv square over r. R here is capital R, right? So I just let me write it. Now they are asking kinetic energy. So kinetic energy expression would be half times mass times velocity square. Now if you notice from first expression, can I get the mv square as a subject? And can I put this value over here? So if you notice, I can get it. R bracket T plus mg equals mv square, right? Just put this value over here. And you notice kinetic energy is half mv square is R bracket T plus mg, which is the option. D is the option, right? This much easy. This much easy it is. There is another way if you notice. First of all, you understand, sir, it is T plus mg, yes or no? So for sure, there should be T plus mg. Gone, gone, right? So at least now you have 50-50 chance. At least now you have 50-50 chance, right? So 50, just mark it. No worries. Save your time. In 50-50, there is a probabilistic ratio. You know that if there are four options in which you did 50-50 and you mark any of the answer, it's a probability that 50% of the questions will be correct. Out of 4, 2 is the probability you can get correct. Math, statistics. Let us move on to the next question. Again, you solve it by yourself and then I'll guide you, okay? Look at this. Sphere of density. Understand, read the question properly. It's a good question. Sphere of density. This is a density of sphere. Write it for a sphere. What is happening? Its radius is r. It is at rest at the bottom of the tank of the water. This buoyancy force is F1. Then we take another sphere but the double the density, half the radius. Again it is at bottom. What is the buoyancy of the second sphere? Understand. What is happening? The first sphere, if you talk about first here, what is happening to the first sphere? The downward force is what? Mg. Anyway, this is not important at all. You just need to understand what. I'll show you, okay? What is F1? What is normal force, buoyant force? Density of the liquid. Right now, this liquid is water times volume of the immersed object. Like how much volume of the object is inside of the water. It is in the complete sphere is inside. So complete volume of the sphere is there, right? Time g. Solve it. Density of water I am not touching. But volume of the sphere I can get it, right? Because they have given the density. What is volume? Density times. What is volume? Volume. 4 by 3 pi r cube of a sphere. So 4 by 3 pi r cube times g. This is F1. This is your F1. Similarly, can we do F2? Density, water didn't change. So density of water remains same. Volume of the sphere is important here because the radius gets half. So if you calculate the volume would be r by 2 whole cube, right? Times g. Technically, you notice 1 r cube, right? R by 2. So if you solve it, you will get, because r cube then 2 cube, right? Indices law. So 2 cube is 8. So 1 by 8 will come out as a factor. Try it, okay? Then density of water times 4 by 3 pi r cube times g is given. Now what we have to do, this is F1, this is F2. If you notice, just take F1 over F2. So F1 over F2, if you notice, F1 is, let us say this value is 1. Big value, don't cancel out. Let us say this value is 1. So this value is 1, right? So it is 1 by 8. So it is 1 over 8. 8 goes up, right? So C is your answer. Understood? That's how you solve it. You don't cut it, cancel out. You can do it. It's not a problem. This is also fine. Understood? Got the understanding of it? Let us move on to the next part. Ninth question. This is really a good question, guys. Really good question. They have given the width of the belt and the belt is traveling at the speed, constant speed is given, guys, huh? The belt has a uniform distribution of charge. This distribution of charge meaning for 1 meter square of it, for 1 meter square of it, this is 1 meter square. For this part, the charge is 5 millicoulomb. Charge is 5 millicoulomb, meaning every 1 meter square section, it will have 5 millicoulomb, 5 millicoulomb, 5 millicoulomb. So like that, 5 millicoulomb, 5 millicoulomb, 5 millicoulomb, 5 mil. This is how the distribution happening. Now, as the belt passes, for sure, the charges get collected here and then they move through the wire, creating the current. So we want that what is the current in the wire? We want what is the current in the wire? Look at the question. Thought. I want current. Current is I know charge over time. So I don't know anything. I don't have anything. But charge I can get it. The charge meaning the total charge. Correct. How do I get total charge? How do you get total amount of the pen? Let us say you have 10 pens and each pen cost is 10 dirhams. So for 10, what you do? You multiply that. Same thing happens here. Same thing happens here. Understand? For each area, this is 5 millicoulomb. So for this entire area, the bigger area, right? What is the charge? 5 millicoulomb times area, right? This is 5 millicoulomb. Answer we'll write in milli divided by time. What is area of this rectangle? What is area of this rectangle? Is length times width. Length, I don't know, let us say L. This length is L, but width is given, which is 0.6. So let us write it. 5 times area is L times 0.6 divided by T. You notice your L divided by T, because your charge is traveling, your L is traveling in some amount of time, right? And this is speed, right? If you notice, distance which is traveled by the charges divided by time of the charges is your speed, which is given again 2.5 in the question. Understood? So this is these two, if you multiply, you get 0.3, which is 2.5. You multiply, you get 0.75 milli. Wait, something we missed. Okay, 3 it should be, right? There should be 3 times 2.5 milliampere, because milli was there, right? So it is 7.5 milliampere. Easy question, right? So understand, these questions are not difficult. The remaining questions I will give you in the next video. All right. But I hope till now you understood. Now, first of all, remember what you should do. You understood how to solve the questions, right? Go and revise your portion. Revise it. Do the questions. Do the questions properly with entirety. Do everything. And in MCQs, there is one more thing which I need to discuss. Try to eliminate. The first thought is elimination. Whenever there are more data is given, try to eliminate it. If not, then try to solve it for sure. Like this question, I used ninth question. I don't know how to eliminate it. So okay, no worries, it's fine. Go to the proper solving. But that bird example, we could have eliminated it. Understood? Now, remember, first of all, I didn't introduce myself. This is Aman sir. I'm currently in Dubai, right? And have an experience in IBDP and all other curriculums of British curriculums like AQ and A levels. But yes, I'm here to help you people so that you can increase your grades, you can get your universities. This is just a small Thanksgiving gesture from my side because people have helped me, students made me here, and yes, I'm very happy to help you people. All right. And in case you have any problem, remember, any problem, this is the number, right? Just connect, not a problem. Everything will be sorted. We will discuss it together. We will sort it out. And this will continue, not a problem. I'll just upload this. Then there are some papers, some difficult questions that I'm going to upload so that you will understand how to approach it. Now we'll meet in the next video. Take care. Bye bye.